In this video, I'll be explaining Hess's law of heat summation. So, Hess's law of heat summation. Now, do not confuse this with Hess's law of thermochemical equations. I'll be talking about Hess's law of thermochemical equations in the following video, but this one is about the first part, just heat summation. And what this law states is that the enthalpy change for an overall process equals the sum of enthalpy changes of individual steps of the process, or in other words, the formation reactions. Now, just to make it clear, it's easier just to write the equation. So, the enthalpy change of our system is going to be equal to, first, the sum of, I will explain each of the things later, of the products. Just let's call it first the sum of the products minus the sum of the reactants. So be very careful with this. It's always products minus reactants, not reactants minus products. So in other words, the inverse as you see the reaction. So just read it from the end. Now let's separate everything into its components. The first thing I wrote was this symbol. If you know that symbol, it means the sum of something. So in this case, it would be the sum of what I wrote here, V delta H, and it's the products of the products. Now, the V stands for the coefficients. So it's a coefficient when the equation is balanced. Well, the last thing I wrote was the delta H. It's just the enthalpy of formation. So, enthalpy of formation. So just to sum it up, the enthalpy change of the system is going to be equal to the sum of the product of the coefficients times the enthalpy of formation of the products minus the sum of the coefficients times the enthalpy of formation of the reactants. And to picture it better, I'm going to solve a problem as always. So, in this problem, we're asked to determine the enthalpy change for the combustion of benzene. So, I'm going to write the equation first. C6H6 as benzene plus oxygen forms CO2 plus water. That's a typical combustion problem. Combustion reaction, sorry. And by balancing it, we get to here 15 oxygen. I'm gonna fix this. "15 oxygens, 12 CO2s, and finally 6 waters. That's 12 carbons, then 12 hydrogens, then 30 oxygens, yeah. And they also tell us the enthalpy of formation of each of the species. You'll usually be given, it's in a table, so you can just determine it. And for the benzene, it's 49. That's in kilojoules per mole. The oxygen is 0, because remember, the enthalpy of formation of an element in its natural state, in its elemental state, is always 0. For CO2 it's negative 393.5 kilojoules per mole. And finally for water it's negative 285.8 kilojoules per mole. And Hess's law stated that the enthalpy change, which is what they're asking, is going to be equal to the sum of V delta H of the products minus the sum delta H of the reactants. So we know that this section right here represents our products and this are reactants. So you'll want to separate it into parts. Let's solve. I'm going to solve first for the sum of the products. So products. That is going to be, I'm going to open brackets. First, our first product is CO2. And the V, as I said before, represents the coefficient. So it's going to be 12. And well, that represents also the number of moles. The coefficient represents the number of moles. So 12 moles. And our delta H, or enthalpy of formation, for CO2 is negative 393.5 kilojoules per mole. So you can see from now that the moles go with the moles, and we just obtain it in kilojoules. And that's good because enthalpy is usually in kilojoules. But that's our first product. This represents the sum of the product, so we have to also put in the brackets the water. So it's going to be 6 moles times negative 285.8 kilojoules per mole. That also goes with this, and then we close the brackets. So for the products, I obtain just V delta HF products negative 6,436.8 kilojoules. First part of our equation. Now we have to find the reactants. So delta HF of the reactants is going to be equal to, we do the same, we open brackets, and let's go back to our equation. Our first reactant is benzene, and we have 2 moles of it. So 2 moles times its enthalpy of formation is 49. So 49 kilojoules per mole. This goes with this. And our second reactant is oxygen. And we have 15 moles of oxygen. 15 moles. And because it's just oxygen, it's in its diatomic form, it has an enthalpy of formation of 0. So you could just say all of this goes away, leaving us with the sum of the reactants. In this case, is about 98 kilojoules, because it's just 2 times the 49. So finally, our enthalpy change of the reaction, or the system we're studying, in this case it's a reaction, is simply going to be the products first. Always remember that. Negative 6,436.8 kilojoules minus the reactants, so minus 98 kilojoules. Simply being delta H RxN negative 6,500 35, about that, yeah, kilojoules. And this is our answer. So that's how you solve a problem using Hess law of heat summation. Remember, it's not Hess law of via thermochemical equations. It's heat summation. And in the following video, I'll do thermochemical equations.